Hi everyone, welcome once again to another tutorial session in bioinformatics. In today's video, I am going to show you how you can use Python to download sequences from the NCBI database. So in order for you to follow this tutorial, you need to have the Biopython library installed. That is the only library you need for this tutorial. You can use pip to install Python libraries, and I have a video that shows how you can do that. The link is in the description box. Now, from the Biopython package, we are going to use these models, the Entrez model and then the SeqIO model. The Entrez model will be used for downloading the sequences, and then the SeqIO will be used for exploring the sequences and also saving the sequences to output files. Now, when we are using the Entrez model, you also need to have the information here. You need to also input the information here in the Entrez model. And the first one is the task you want to perform. Because we are going to do downloads, we are going to import from the Entrez model here the fetch method. That is what we are going to import. And then once we import this method and we are using the method, we then need to specify these parameters here as well. And the first parameter is the identifier, where we use ID. So the ID can be the accession number, or it can also be the GI number. These are the two types of IDs we are going to use for this tutorial. Now, we also need to specify the database from which we want to download the sequences. So we specify using the DB parameter. For this tutorial, we are going to focus on nucleotide and then the nuclear databases. So I'll give examples of how these are done. And then you also need to look at the output formats of your sequence. So to do that, we specify the read type parameter, and then this tutorial we are going to use the fasta and then the GenBank, meaning that we are going to download our sequences in the fasta and the GenBank formats. I'll show how all these things are done. And you also need to input the display format. So the display format is, if let's say you want to print your sequences on the screen, then what format do you want it to be displayed? So we use the ret mode parameter, and then you can display in text, or you can also use XML. For this tutorial, we are going to display everything in the text format. So this is just a summary of what we are going to do. So once you have your Python library installed, you can now proceed with the exercise. So let's begin the activity. So the first thing we do is to import the models from Biopython, and this is how we do it. We import them here. Then you set your email address. This enables NCBI to know you. So I'll say entrez.email equals, let me say, bioinfo.coach@bioinfo.com. It's my mail. So I have it done. So once you have this done, you are now ready to download. So what we are going to do first is to download and view the sequences. We have them here. And here we are going to use different options so that you get to know how to use all those parameters I made mention of. So let's begin with this example here, where we download the sequence using the GI number as identifier, and the database is nuclear. So we say handle equals entrez.fetch. Then the parameter is db nuclear. Then we say ID. It should be a string character, so let's give this ID 3455776777062. Please note it should be a strange data type, so we have it there. We are going to leave everything with their default settings. So let's run this. So we have fetched the sequence. So let's print it. So this is how we display it of view. You say print handle.read, then you print it. So this is how it is displayed for us here. This one, I think, is a JSON format because we didn't specify the rest type. That's the output format here. So by default, it is giving it to us as JSON. So let's look at the next commands where we use the same information here, but this time we return the output as fasta formats. So let's go here. So we say handle equals entrance.efetch db, same as previous, id same 345-77062. Then this time we say red type equals faster. So let's run this and then let's view or display it. We say handle.read. So notice how the output format has changed. Now this is the faster format. So we have it done here. So let's try another one where we change the database to another one. So let's use this. Let's use this here. DB will be nucleotide. The identifier will be accession number, output formats, GenBank, and then the display formats text. So let's try this as well. So we say handle equals entrance.efetch db equals nucleotide. ID equals, this time we are using an accession number. So let's use say nm underscore 001126.2. We are using the accession number for this one. This very one here, the same as what we are doing here. So, and then what we have is, we say output format is GenBank. So that becomes rest type because GenBank we use GB. Then write mode, that's the display format text. So we have it complete. So let's run it and let's print it. You say handle.read. So we have it displayed here. Notice the GenBank format for this. So let's just go up and then display it here. So that's how the GenBank format is. Now I have separate videos that shows how you can use Python to read faster in GenBank files. So I will leave those links in the description, but you can use that to also explore more on this sequence file formats. So we have this there. So based on this information, we were able to return these ones here. So we are on track. So what we are going to do next is to download and explore the sequences. So this one, we are going to also include a SeqIO model. So let's try with this first example here, where identifier is accession number, the output format will be faster, display mode will be text. So we are going to use the same accession number we had here, this one here, just so I can explain X. So we still begin with the handle equals entrance.efetch db. This time let's use this. Let's say nucleotide. Let's use the nucleotide database. Accession number, that's ID nm underscore 001126.2. Output format faster. So let's type equals fasta. And let's say red smooth equals text. Let's make sure the same or similar commands we have here. Okay, so we are good to go. So this time let's run it, but then we have to put this in quotes. So we put it there. If you don't put it in quotes, you have some error. So we correct it. So let's put all of them. So we are now good to go. So let's run this. So after running to get the handle, because we are going to explore, we need to convert it to record. That's the bio record, bio.record data type. So we say record equals SeqIO.write. Then we say handle. Then we indicate the format. Because we are returning fasta, we also need to indicate fasta here. So we read it. So now it's a record, a sequence record in Biopython. So now you can explore it. So the exploration is still the same procedure or steps as I displayed in an earlier video where I showed how you can read and explore fasta sequences. So once you have it in this format, the record SeqIO format, the record, you can just explore it. So let's say if you want the ID, you can say record.id and you have it there. If you want name, record.name, you can also have it there. If you want, let's say description, record.description, you also have it there as shown. If let's say you wanted a sequence, you say record.seq, that'll give us the sequence. Let me just put this comment here for you so that you know what they are. So we are dealing with the sequence name and sequence ID. And we also have the description. Yeah, so now we want the sequence itself is here. So that one becomes record.seq. So here you can let's print some few, let's say the first 10 bases. You can say seq 0, 10. You can have it there. You can also check for the length. Let's say length of sequence. You can say length seq. And we have it here. We have 2775 bases. That's for it. You could also print the entire sequence here. But this one, I recommend you do it if your sequences they have a short length like this particular one here. So that's how we do exploration, by first downloading and then explore. There are a number of things you can also do here, such as maybe checking for codons, and there are a whole lot of things you can do with the Biopython library once you get them into this particular format. So that's how we do the exploration, and by getting the sequences in fasta formats. Let's try with the GenBank formats. So if you are going to use a GenBank, let's do it here. We will still use the same parameters, but this time the output format changes. So let's say handle equals Entrez.efetch. We can use the same, we are using the same commands as we had here. Let me just copy and paste this one here. But then this time, the format will change here. This becomes GB, meaning GenBank format. And so you can just say record equals SeqIO.write, handle format is GB. So we run it. So from here, it's a seq record object in the GenBank format. So let's say record.id. You have it here. There are a number of things you can do here to even get the features. Let's say record.features. You can get them here. So let's say features equals record.features. So let's say if there are a number of features here, say len features. The features are 5. Let me just put this comment here. Sequence ID. So we have 5 features here. You can even print the features. Let's see. These are the features we have here. But of course, this is just one sequence. So it's a gen. So if you're expecting to see a variety of features here, this result here wouldn't give you much because it's just a single sequence that we have here. So depending on your questions, then you download the appropriate sequences and then just explore. So we have it here. You can also check the sequence. Let's see. Sequence will be what? Seq equals record.seq. And you can even print it. But now let's just print the length. The same as we did with the other one. You could also do some stuff like, let's say, seq dots, and then find its location. If, let's say, it was a full genome and you had this feature as one of the records, then you can just check where it starts with, where it ends with, and a whole lot of other things. So these are cool things you can do with Biopython by getting your sequences downloaded for you. So we are on track, and these are interesting things that I will encourage all of you to try if you are dealing with multiple sequences. Now, so far what we've done was to download single sequences, but Biopython allows you to download more than one sequence. So you try and then just download multiple sequences as well. So if, let's say, we are downloading 2 sequences, we know their GI numbers, then this is how we do it. See, multiple identifiers. Let's put it that way. We are using 2 of them. So we say handle equals Entrez.efetch db, let's say new call. And then when we come to the ID side, there's still a string data type, but this time we specify both. We say 3457706 2. Then we add the next one by introducing a comma first, and we put that one there. Let's say 186972394. So now we have the 2 sequences there. Let's say we are returning it in fasta formats. So we have them there. So once we have it like this, we can just run it, and then we can print it. So we have the 2 all printed here. Now we can also just read them as records and then explore. Let's use the same thing here. Let's do this. Let's say we want to explore it. We can just say records equals SeqIO. This time, instead of read, we use pass because we are dealing with more than one sequence. Then we say handle, and we indicate the format, which is fasta. So we run it, and then we just iterate. So we say records equals I for I in records. So now we can check how many sequences. We are expecting 2. So once we do learn records, okay, we have 0 here. Yeah, I think I didn't run it. Let me run it here. Yes, so now we can get a 2. Yes, so what happens is once we have this handle here, it downloads the sequences and it holds them temporarily. So sometimes you might have to rerun it again to get your sequence back. So that's what I just did. So we now have 2 records. So these are the records, yeah, from these sequences here, these IDs here. So we can check their respective IDs. Let's say records 0. Let me just do it here. Let's say first record equals records 0. Second record equals records 1. So first record.id, we have it here. Second record.id, we have it there. So you can just explore just as we did with the first one. Again, I have a video that shows how you can read multi-fasta files. So you can use that to get started and get more information about how to explore these sequences. So because we are dealing with 2 sequences here, this particular result here, when we save it, it becomes a multi-fasta file because we have more than 1 record there. So this is how we do it with downloading multiple sequences. So what we are going to do next is, what about if we want to save the downloaded sequences? It's possible to do that in Python. So far, we've been working in memory with Python. So that means if we exit Python, all the sequences we downloaded also goes away. So we need to save it in an output file that we can later read. And that is the next activity. So we are going to use 3 different scenarios here. Here, the output type is GemBank and it's a single sequence. So this is how we do it. We say handle equals Entrez.efetch db, let's say nucleotide id, let's say 345 77062. Let's say red type equals gp. Then we read it using the SeqIO. We read it. Then we also specify an output name. I'll save it in my desktop, so I'll give the full path. So I'll say /home/ this desktop. Then I'll save it. Let's look at the name that was for it. For this one, okay, so ADSS. Let's just give it that name here, ADSS. We'll save it like that. So I say ADSS.jp. You can also leave all these things out and just save it here. But when you do that, you need to make sure you know which paths you are working from, and then you can go and then check it out. So this is how I do it. So I'm going to run this and then we'll see how it saves it. But first, let's correct this. This is supposed to be GB. Yes, so that we have it there. If you don't specify the correct words or terms or options, you get an error. So make sure everything is correct. So now we can now run and save it. So we have run it, and it's now time to properly save it. So far, what we did was to read and then convert it to a record and then also define the output name. So now we use this command here to save it. So the output name here is what we define here. And then we also have the record. That's what we have here. So we run this, and then it's going to save to the path we specified. So once it's saved successfully, we have a number indicated here. That indicates the number of sequences in that record. So when we go to my desktop, you find it there. So let's go to the desktop, and there's it. There's a GenBank file we save. You can open it with any text editor. Let me open it. And there's the file here. There's the GenBank format. So that's how it is. Okay, so that's the GenBank format. So we have successfully downloaded and saved it onto our desktop. So let's go back and then save the others as well. So let's look at the next scenario. That is, output type is fasta. So here we use the same command here, the same record here, but then we change the format here to fasta. And then when we come to the output name, we say .fasta. We are using the same path, so we are going to find it. So we run it, and then we now save. We say SeqIO.write, record, output name, format, fasta. So it is also saved on the desktop. Let's go and check it out. So let's go. So there's a file here, adss.fasta. So open it, and then you have the fasta file here. So here, once you have these files, you can use Python to read them. And I have videos, and I'll show them in the description box as well. So these are the two. Let's look at the next scenario. So if, let's say, output type is multi-fasta, that is why we have multiple sequences downloaded. This is how we do it. So here, let's use the same command here. And then because we are dealing with multiple sequences, let's add the next ID, which is this one here. So we have these two here. So it's the same. We give the record here. This time it's pass. Let's add the output name. Let's say ADSS dots. Let's say this one will be 2. So let's look for those names. Yeah, we have MATK. So let's put that one also here. ADSS MATK. Let's check. Yeah, so that's the name. Let's give it that way. So then we run it, and then we say SeqIO.write, record, output name, fasta. And then notice now we have 2 displayed here because the record contained 2 sequences. So now we have saved that as well. So let's check that on a desktop as well. So there is it, the ADSS MATK. So we have the first sequence here, and the other sequence also here. So it's also done for us. So this is how I bring the tutorial to an end. And again, I say that I have videos that shows how you can use Python to read each of these files here as well. The fasta sequence, the GenBank, and then the multi-fasta file as well. So check them out to help you with your exploration. So this is all I will say for now, and I hope to see you in the next session. Goodbye.